Wait a minute now.
Oh, I'm coming.
I don't see anything.
All right, it's not working. Yeah, we don't want to hold the parents up.
Can I do your hand? Let me see if it. Okay, it's good.
Okay, everybody like that? All right, welcome to Math Parent.
Before you start,
You
since
go
our
right
Mr.
ahead.
Eddings remembered after we reminded him about playing games, so if the students would like to go play games, he's gone and gotten all the games, so he's gonna be in the cafeteria. So if you wanna go play games, they're doing that now. Okay, so if you don't wanna go play games, then you can stay, but if you wanna go play games,
Because what we're doing is the same thing we did this week, so you'll just see the same lesson over again.
I'll just take them.
yeah.
But at least y'all like stop and really talk about what should we do.
They love that.
I'm today.
Well, thank y'all for coming.
Are you gonna stay? Yeah. He loves math.
Miss
so.
Reverend and Miss Price, would y'all like to get your table? Sure. You're all we have right now. Oh, yeah.
Yes, Laura.
So we get to the dancing parent part, y'all put on a good show for us.
Okay.
Well, welcome. Tonight, we're gonna be talking about expressions, equations, and functions, but with a focus on functions, how it all comes together. All right, Ms. Harris?
Okay, this is an example where actually we had the same good chart this week in class, and this figure is made up of 3 different types of shapes. All right, and so our input-output table, which we call function table in math in the 5th grade, says if the number of fish is 1, and of course it's made out of 3 different shapes. This is a, can you help me out? All right, this is a
Hexagon.
and that is a
Trapezoid.
trapezoid, right, okay, now, if we're gonna actually get into all the quad family coming up. So, if I've got 1 fish, I've got 3 pieces, 1, 2, 3, okay? If I got 2 fish, thank you, Ms. Gaines, and I have,
6.
how many pieces? 6, 1, 2, 3, 4, 5, 6. Okay, so now we see that some pattern is developing. So now I have 3 fish, and you can count them. 1, 2, 4, 6, 7, 8, 9. Should be 9. Okay, Ms. Gaines, can y'all think of the rule here?
Times
What's
3.
Some rule times 3, exactly right. Okay, now let's go down to 10, Ms. Gaines. Let's do a little bit. So 10 times 3 is
30.
30. All right, so if I had 10 fish, I'd have 30 pieces. Okay, now here's another example. I've got a flower. All the little petals, what shape is that?
Triangle.
Good. In the middle, what shape do I have?
Hexagon.
Another hexagon, right, because it's 6. So we're going to have another rule developing here. So 1 flower is a total of how many pieces?
7.
7, great. Okay. All right, so I got 1 flower with
7 pieces.
7 pieces. All right, so we're going to jump to 2 flowers.
14 pieces.
14 pieces, okay. Great. All right, now I'm going to do 3 flowers.
21.
Absolutely. Okay, now, can you think of the rule?
7 times.
Times 7. And we're going to look at the rule, and we're going to move to the 8, Ms. Gainey. So if I have 8 flowers times 7, 8 times 7 is,
56.
I'm going to have 56 pieces. No, we're good. You're good. All right, Ms. Miller.
So that was 2 examples of what, as Ms. Harris said, we call a function table. In 3rd grade, they might would have seen something like this called an input-output machine. And if you look at it, 24 went in and 21 came out. So, which one of these rules would apply?
Subtract 3.
You got it. Subtract 3. So we kind of start in 3rd grade with that at a simpler scale using machines, and I've seen them before where they put the number in the top and it comes out the bottom. 4th grade, they start seeing in and out using those words. If we put 6 in, 12 comes out. If we put 22 in, 28 comes out. What would the rule be?
Plus 6.
plus 6. Now, the reason it took Ty second is because we teach them, you don't just look at the first level, because it's a rule, it has to work every single time. And we want them to persevere. Or, you know, like a rule in the classroom applies to every student. The rule has to apply every time, because you might would initially think times 2. But when you get to the next one, it doesn't work. Plus 6 is the only one that works every single time. 5th grade, they start using variables, the X and the Y, and they're seeing the equation, and they also have to create the equation. So in this case, instead of just writing, like in 4th grade, plus 6, or 3rd grade, minus 3, they have to be able to tell us what's happening to X to give us Y. So in this case, when I see this, I know they're telling me multiply 3 to every single X. And 5th grade is usually when they discover that a number beside a letter means multiply. And I tell them that we're getting them all ready for middle school. They have to really retrain their brain because they're used to this meaning multiply. But of course, you don't want to see 3xx. It's very confusing. So we just put the number beside the letter. And what would this be?
3.
Good job. What would
15.
this one be? All right.
18. 24.
All right. Somebody's making a
Snuck
day.
on one in there for him.
I know.
Credit.
Okay, so this is another example which requires a little bit more effort, a little bit more thought. And of course, real world. After school, Selena walks some of her neighbor's dogs. She earns $2 for each day, and when we're doing this in my room, and I know a lot of it, I have them circle the numbers because it brings that to their attention. So she earns $2 for each day she walks the dog. Last week, she walked Bandit. How many days?
6. Oh.
How many days?
Days.
4. Okay. So I'm gonna circle that.
Good job.
I seen the answer on my own. How much money did Selena earn walking Bandit last week? And I tell you what, I have them underline the question because that helps. All right, now I'm gonna skip this for a second. And here's my function table. It doesn't matter whether this is horizontal, it could be vertical. All right, either way works. You can use the function table to show the number of dollars Selena earns for walking dogs for different numbers of days. The table matches each input value, which Ms. Miller told you, N meaning days, with an output, D meaning dollars. It shows a function. So what I'm going to do is, since I'm working with 4 days, I'm going to number starting with 1,
2.
go to 2,
3.
all right?
4.
Now,
5.
this is going to answer my question, but I've got extra spaces, and I'm going to go on and fill that in.
6. 7.
Okay?
Good job, Kyle.
All right, so I got to come up with some kind of rule that's going on, all right? So I earn $2 for every day that I walk the dog. So if I walk the dog one day, how much money do I end up with?
$2.
$2.
4.
4.
6.
All right, now can you see 1, 2, 3, 4, 5, 6, 7, a pattern, 2, 4, 6, developing here? Okay.
8. 10. 11. 12. 14.
Okay, good job.
You have to be
All right, so now, which one of these numbers is going to answer my question?
4.
The 4. Okay, so if I walk the dog for 4 days, how much money am I going to earn?
8.
$8. Okay, so now I've got a rule, and I'm not going to uncover this until we can figure out what that rule is.
2
Parents,
times.
you figure it out?
2 times.
So actually what I'm doing is multiplying by 2. But you got to check it out. I could add 1 to get to here. But 1 times 2 is 2, and it's working. 2 times 4 is 2, 3 times 2 is 6, 4 times 2 is 8, so forth. And then we can write it using the multiplication symbol or side by side. That means times 2. Or we also can use the dot. Okay, one more example. The hospital is donating half of what you spend in the cafeteria to a local charity. How much did you spend if they donated $5? How much did they donate if you spend 12? Here you can see that this function table, again, is horizontal. is missing a couple of numbers. And that is what the questions are asking. All right, let's circle the numbers again, so we can see what we're working with. All right, I'm going to underline the question. What's the questions? I think I see two.
How much did they
Okay.
donate?
And how much did they donate if you spend $12? Okay. All right, so if I spend $2, they're going to donate.
1,
Okay. If I spend $4, they're going to donate.
2,
If I spend $6, they're going to donate.
3.
Okay. And you know what? I see a pattern developing again. I see a pattern on the bottom also. All right. And so I'm missing a spot here. And can you figure out the rule?
Minus, no.
Could be. Well, we have to check that out. 2 minus 1 is 1. 4 minus 1 is 3. That wouldn't work. Okay, let's look at it one more time.
2 times 2.
Okay, the top number is bigger than the bottom, so I know I've got to be doing either subtraction or division, right? I know it's not subtraction, we checked that one out. Okay, if I were hopping 2, 4, 6, 8, what would come
10.
next? Okay,
6.
and 6. Okay, now let's figure out the rule.
Divide by 2.
5 by 2, absolutely. All right. So Miss Candy's gonna move that over and we're gonna check it out and see if it's right. All right.
Well, I have a question. Will they get to the point in 5th grade where they're multiplying by fractions like 2 times half is the same? I'm just curious. Like,
Isn't that
very-
next year we will be
They'll-
teaching it? It's
they'll
kind of like
get
one
it.
of these come together years,
It's
something
not, it's not in common, so
Right,
they'll,
it's-
we'll teach it, but they won't be responsible.
I guess I was wondering like if it would ever get to the point of they could choose division or multiplication by a fraction. I just
Right.
wonder.
Gotcha.
It's like one half, like it could be 1
I know,
half
yeah.
n
Yeah.
equals, what's that one, d.
Right.
Our rule of thumb is just to maybe expose it to them, you know, in the event they see it, but they wouldn't be tested on it this year.
Right. I think I have one more example. Jake's cousin's 15 years older than he is, and this is a number in word form. How old will the cousin be when Jake is 7? How old will Jake be when the cousin is 23 and 24? All right, so I've circled my numbers and my question. I have 2. Okay.
Everyone don't like that sound.
My board doesn't really do that. But anyway, I've got, when Jake is 4, his cousin's gonna be 19. Because he's 15 years older, right? 4 plus 15 is
19.
19. 5 plus 15 is,
20.
6 plus 15 is,
21.
7 plus 15. And you can also see a pattern.
Oh, 22.
22, great. All right, and I'm going by ones here, so what would be
8.
next? Right.
9.
Okay. And what's the rule?
Plus 15.
Exactly. And 15. All right, so the value of the output depends on the value of the input. Great job.
And that's all a function is, where the x, the y is dependent upon the x. And I tell the kids that you use this all the time. You know, if your parents tell you work 1 hour, you get this much money for every hour, they're doing functions in their head. Like, oh, I'm gonna try to do, you know, my child gets $1 from grandma for every chapter book she reads. So she realizes 1 book is $1, 2 books is $2. So they have experience. But we also teach them that a function can be written in word form, which is what Ms. Harris just did. It can also be written as an equation to help us figure it out, which is what we just did as well.
Or
A table, or also what?
a grid.
A graph. They have to be able to interchange those. So if you look at this one, the rule is 2x plus 4 equals y. And I always like to tell my kids, what's happening to x to give me my y? And actually this particular day I told them, you're gonna get your mama's gonna give you twice as much money as she gives your brother, plus your daddy's gonna give you extra dollars. putting it in context makes it realistic. So if mama gave brother $1, or if brother has $1, you're gonna receive
3.
3, because 2 times 1 is 2, plus 1 is 3. And that's where order of operations comes in handy, because they have to know multiplication comes first. If brother has $2, you're gonna receive
5.
If brother has $3,
We would have 7.
if brother had $4
9.
and $5.
11.
And it takes a couple days for them to get comfortable with using function tables. But then we tack on graphing it, which is really simple. They pull off those ordered pairs. And of course, in school, we learn that ordered pairs is X and Y. We explain the same thing to them. It's in alphabetical order, and you just pull them off in the same way. So my ordered pairs would be 1, 3, 2, 5, 3, 7, 4, 9, 5, 11. And this, they've been doing since 3rd grade, plotting points. They love those. So once they do that, and they always know, Ty, where do we start on the grid whenever?
We start on the left.
What number is at the left?
0.
Good job. I always start at 0, 0. So my first one is 1, 3. So I know I have to go over before I can go up. Over 1,
Up 3.
Start at 0 again, over 2,
2. Up 5.
over
Over
3,
3. Up 7.
Over 4.
Up 9.
over 5,
11.
and then,
Cover line.
okay, it's going to be an ugly line. In class, I have a little tool that makes it all pretty. You connect it out. And we discuss increasing lines and things like that. So that kind of brings it all together. All right, now it's parents' turn. Ty, we'll see how they do.
Okay.
Here's the word form. A school dance is $5 per ticket. The reason that's underlined, we talk a lot about keywords. Each, every, and per means multiply, and they know their addition words and subtraction words. So a school dance is $5 per ticket. Which function table matches how much it will cost to buy X amount of tickets? Okay, we have a C. Y'all agree? Ty, is C correct?
Yes.
Explain why C is correct.
Because you're multiplying 5 by 1.
What would my rule be? What's
Okay.
happening to X to give me Y?
X 5 equals Y.
All right, good job. And the only one that fits that, making sure you test everyone. This one, if you test it out, is +5, so we know it does not work. This one starts out correct, times 5, and this one does too. I like to tell my kids, this tells the difference between the lazy child and the child that perseveres. It's like, oh, it works, I'm done. But if you would have gone far enough, it doesn't work for those two. So C is the only one that tells me if I buy X amount of tickets, this is how much I'm gonna pay. Same situation, but now in graph form. And we would have the students pull the ordered pairs off of their function table, which was 1, 5, 2, 10, 3, 15, 4,
20.
20,
5,
and
6,
5,
25.
25. All right, parents, and Ty, you got to check and see if they're correct.
Okay.
Which graph would match our ordered pairs that came off our function table?
C.
Yeah, I know, it's a little small. When you get to C, we start at 0. Over 1, up 5, check. Over 2, up 10. Over 3, up 15, and so on. So C would be the correct graph. All right, another situation. Julius and I visited a delicious cupcakery called Cupcraze in Fort Mill, South Carolina. The owner was one of the winners on Food Network's show called Cupcake Wars. When we went, each cupcake was $3 plus $1 for coming into the store. Which of the following would be the function rule? And again, we would reiterate what's happening to X to give us our Y. I'm gonna check and see if you know which one it is already. Don't say it, we're giving the parents a chance. And in class, we usually have like the kids doing thumbs up or something to indicate. Okay. And we do encourage think, pair, share, and all that stuff. All right, Ty, is Ms. Redfern correct?
Yes.
Okay, explain why, Ty, it would be 3x plus 1 equals y.
Because every time when they buy a cupcake, it's $3, and then they have to pay one.
Right, each cupcake is $3 and then $1 to get in. And I tell my kids, this is a true situation, but you don't have to, if you ever want to go by it, you don't have to pay $1 to get in. I tack that on to make it a little bit more challenging. All right, Ms. Kane. So it would be 3x plus 1. Same situation again, but a different look. This time, which table would match the situation? Now, we would want the students to remember 3x plus 1 equals y. So if I bought 1 cupcake, how much would it cost me? If I bought 2 cupcakes, so on and so forth. Parents, do we have a solution?
I'm thinking A.
All right, let's test it out. If I buy 1 cupcake, that is 3 times 1 plus my, plus my $1 to get in. So 3 times 1 is 3, plus my $1 to get in, 4. So as of right now, it could be A or B. We know we can get rid of C. So let's try 2 cupcakes, which would be
3 times 2.
3 times 2 plus the $1 to get in.
7.
That's right. So that would definitely be A. Good job, Mama Price. Same situation, but this time the graph. We would have the students look at their function table and pull off their order pairs. So 1 cupcake was $4, 2 cupcakes was $7, 3 cupcakes, $10, 4 cupcakes, yes, thank you, I have them over there, 5 cupcakes, $16. So we're looking for the graph that has those order pairs. Ty, what do you notice?
A.
We'll cut the parents some slack on this one. The line's a little small. All right, you're thinking A, let's look.
Let's say B. I think it's
All right,
B.
yes, we'll look at A over 1, it stops at 3. But it's because it's so small, you're way back there. See, let's test it. Start at 0,
B.
over 1, up 4, that matches that one. Over 2, up 7, over 3, up 10, over 4, up 13, and over 5,
15.
16. So it is definitely B.
Those small little ones mess me
Yes. Right now it's your turn. Let's have that look. And all you're going to do is we're going to give you a function table. Complete your function table. Write your ordered pairs underneath it, and then graph your ordered pairs. So you have your own. Wait up.
I'm ready. Come over your time and sit down with your mom.
Or do we need to have Ty walk around and make sure they're doing it correct?
I think
And you can write on this. Yes, they're different. Oh, here you go, Ty. And make sure you connect your dots.
Okay. Okay, you said one time, like go to the elevator and then go.
That's a great example.
The president of the company, his secretary, say, would you like to see Mr. Price now? And she'll return a note, yes. And she'll give you a note to go by him.
It's kind of hard to get on the 5th floor without going over. And we've noticed with the kids, it is a little easier when you put it in a real situation. You just said me, I've been working so hard.
Done.
Ties done. Now let's look. Let me start at 0. Alright, let's move over here. Because remember, you're gonna over and then up. So our order of pairs is 1, 0, 2. Okay, hold on. Let's write 3 times 1 minus 3. That's right. 3 times 2 is 6 minus 3 is 3. Good job. 3 times 3. So you got that. So your order pairs 2. The ones we've done have always been straight, and I think, if I remember back to my Miss Sweeney days, the only way to be decreasing doesn't have to be a negative variable, like it has to be a negative x. And I told them that today because they're like, well, is it ever going to go down? Because a lot of them think it'll be a decreasing line if it's subtracted. It's still increasing, it's just lower on the graph
Yeah.
than this one.
And it's a
Right.
straight line and it functions synchronized. The X and the Y, right?
Okay, that's right.
Yeah.
Or else it wouldn't be a function table, would it?
Yeah, because if it doesn't fit on that straight, then it doesn't match with the,
Well, I was telling
It
y'all, this is
increases.
the foundation for algebra. You know, a lot of them will be into that in the next
Right.
year.
seventh grade, because I had that last year.
Trigonometry too.
Mhm. Yeah, they do slope, intercept, it starts in 6th grade, then it goes a lot deeper in 7th and 8th.
And that's really why we don't let them do, we let them, but we really encourage the algebraic look of an equation. So it won't be a big shock factor next year. Because a lot of them say, well, can I just put 2 times in? Like you can, but go ahead and get used to that. We're trying to train their algebra brain. Because it's hard to go from 3rd grade, just being exposed to multiplication, to 5th grade, a number beside a letter. I didn't even know you could do that. But they picked up on it pretty good. And y'all all have your increasing lines. Good job. Good job. Ty, was yours increasing as well? All right. Any questions, parents? This is what we've been doing. Next week, yes, they'll be tested on it. So we're kind of concluding it now. Graphing was the last thing. We're going to talk about equations some, and then we'll test them. So if y'all have any questions or concerns or thoughts, thank y'all for coming. Unless you want to do a couple more.
Yeah.
Yeah.
We'll send them home with them.
Oh, yes.
Thank y'all so much for coming.
Yeah, thanks for coming.
And you can take the one that you did, and if you want to take the